Hey, how's it going? All right. Thank you, everyone, for coming tonight. I really appreciate the enormous turnout we have here. When we were kicking this off, I was a little worried that we weren't going to get a huge crowd worthy of the 75th anniversary. What's up? I am unmuted. Am I not unmuted? Oh, now I'm unmuted better. Okay. All right. Yeah. So to see all of these faces here and all of these people here is really exciting. I think at last check we had almost 90 registrations, and so we exceeded 75. Right, one for every year. We'll be assigning them one by one. But no, I'm really excited about all of you coming. Our organization's been around now for 75 years, and when I look around this room and I look at the folks who represent sort of the past 75 years and the building of the optics community in this area, and then I look around and I also see the people who are going to build it for the next 75 years, I'm really heartened. This is really exciting. And one of the questions I've been asking myself over the past year is, what's the role of a local professional society? And when I think about all these talks, and when I think about the conversations that we're having in this room and what we bring together here, I get the answer, right? It's this dialogue, it's this rooms like this where we can all get together, swap jobs, talk to each other. It's a great time. So with that, I'm going to keep my remarks brief. Logistics. It works. All right. We have had a request from the speaker to not, if you're on Zoom, record the keynote speaker yourself. We are recording, but we have to get the talk approved by NGM for the YouTube channel. So please don't independently record this talk. Also, with over 80 people between this room and the online audience, please hold all questions for the end of each talk. I know there's a lot of excitement about it, but we should have ample time for questions in each sub-talk. We may have to cut off questions in our society history talks just to keep things moving ahead. Rachel in the back is monitoring the talks on Zoom. So if you are a Zoom attendee, just chime in and type your comments in, and they'll get addressed to the speaker. Regarding refreshments, please help yourself. But at the end of the talk, we do need to keep the room clean. So please just make sure you clean up after yourself. We do have dinner planned for after this talk. We have the banquet room reserved at Sumiya Hunan Kitchen. It's about a 10-minute walk away, just up the street over there. It's really easy to get to. We don't have a huge window between when our reservation is and when we intend the talks to end. So while I know that there's a strong desire to schmooze, we can schmooze over food over there. They've got a better cocktail menu than the MIT Museum. And there's room for, I think, everyone who registered as that they were going to be joining. I want to give a big shout out to our sponsors. Our sponsors make this possible. All of the organizations that have been a part of NES Optica and NES OSA over the years really are making this sort of thing possible through your financial contributions, your continued supply of people and volunteers. So please give them a hand. Got only a couple more slides. One is I'm going to make a pitch for you to become local members. If you are a national affiliate, and I see some new faces here that I think are national Optica affiliates, but not local members, please go to our website, nesoptica.org, and sign up at least for our mailing list, if not for a membership. And you'll be notified of all of the interesting local talks we have. Usually they're somewhere along the 128 belt, either at Opticos or at MIT Lincoln Laboratory, or other places in that area. Always interesting, exciting talks. Our next talk, just to tease this, will be on October 17th at MIT Lincoln Labs, and it'll be about wrinkle detection systems for web-based manufacturing of medical pressure-sensitive adhesives. I've heard this is a fascinating topic. I don't know anything about it, but it's I'm excited for it. The other thing I'm going to tease before we turn it over to our first speaker is that we do have a society time capsule. Now, when we were planning this event, we assumed that we were going to be bringing it out here tonight. But Andy informed me that written on the top, it says, do not open until 2025. So I think we're going to be opening this at our business meeting in the spring instead. So my ask for you, for everyone in this audience, is think about what you would want to put in the time capsule that will be opening at our 100th anniversary, because when we open a time capsule, I think it means we have to build another one. All right. So our agenda for today is pretty action-packed. We're already running about 10 minutes behind. We'll make up the time, I promise. We're going to have a really great talk by Jeff Hecht about optics, the state of optics in 1949. Then Steve's going to talk about various members of the local optics community who've really pushed optics forward, members of our society and others. Joe Houston's going to give a remote talk on the iTech years of the local optics world. And then we're going to try to have a brief break before we go into our keynote address with Stuart Elby. So with that, I'm going to turn it over to Jeff Hecht.
Thank you very much.
Yeah. All right.
I'm going to take us back to 75 years to 1949. Actually, I'm going to take us a little bit more than that. I'm going to go back to the very early optical industry, where the first industry in optical industry really in America was eyeglasses. Started and became really a factory mass production in the late 1980s. And there was actually quite a bit of a number of optical societies who were opticians and making eyeglasses back around the 1900 range when you find it. Now, there also was a camera, and cameras came, and photography really became popular after the Kodak Brownie. This is what we're showing you here. This is the first type of model of the Brownie, and this really made photography popular and something everybody could do. The Optical Society itself, the Optical Society of America, as it was called, was founded in 1916 in Rochester, pushed by the government's concern that they needed more optics because at that time, the optics industry, all the good stuff was made in Germany. And all the highly skilled opticians, or almost all, and all the optical glass was made in Germany. And if we were about to run into a war with Germany, which we were, we needed to have more skills in the US. In the first, after the first year, the National Optical Society, which had expanded from Rochester, had 87 members. Now, that's a first start. Now, I'll give you another number for what the local section here had. when I get down to it. And there was also industry for optical instruments, military, uh, binoculars, scientific use, uh, astronomy, microscopes, uh, and that kind of thing. So now we're getting into 1930s and 1940s, and things started perking up. In the civilian world, it was photography and cameras and the development of color film. This is uh, a ad from 1947 National Geographic pitching Kodachrome for your miniature camera. And you could actually buy, uh, there were actually also home movie cameras that used the Kodachrome. And this was fairly well distributed in the population. This just wasn't the 1%. Uh, my wife has slides from her family from Kodachrome sometime in the 1930s, maybe 1940s, and she has a film, the color films on 8mm film from the 1940s. So yeah, this was a widely uh, used technology, and amateur telescope making as well. And there also was a lot of military action because aerial surveillance in particular and aerial defense became very important after World War I showed that bombers could go around and bomb people, and you wanted to stop them from doing that. Then and there also was more, they needed better binoculars in the field and things like that. So there were restrictions by the Depression. And but there was also a lot of stimulation of new technology driven by World War II. So this is an example. The picture here is an example of one of those technologies. Brian O'Brien, who was the OSA president in 1951, was at the University of Rochester, and what he had made was an acaroscope, and what that did was it was a nonlinear device that allowed you to see both bright and faint objects. And what they really were interested in, they wanted to see airplanes that were trying to attack by coming in so they were right in front of the sun, so you couldn't see the plane because there was all the light from the sun. And there was other optical technology. There was infrared night vision, more improvements in aerial surveillance, precision optics, spectroscopy, which was used for identifying things, and radar, which was not directly in the optical spectrum, but was really instrumental in helping develop the laser, because the idea of stimulated emission was first demonstrated with the laser. So we've got optics was small, but it was growing. Now, there was a lot of revolutionary technology in that came out of World War II. Optics really wasn't much of the optics then wasn't very revolutionary compared to solid state physics, semiconductors, microwave technologies, electronics. And there's an interesting story. I interviewed with Jay Last, who was a pioneer in electronics, and he actually had graduated from the University of Rochester's optics program in 1952. But his professor warned him that optics was limited, and he could see that. And he went to MIT in solid state physics, and became a semiconductor device pioneer at Fairchild Instruments, which was making the first integrated circuits and the pioneering in integrated circuits. And he used his instrument, and he ended up using his optical knowledge to develop photolithography, which is vital to all the semiconductors that produce today. So you can see that optics had its role. And there was also optics that was hot in 1949 when we started out here. The 200-inch telescope in Palomar. Polaroid's instant photography had been actually demonstrated first in 1947, but it was being commercialized about 1949. There was aerial surveillance, which had actually grown greatly in Boston in the 1940s. And there were things like black and white television because color television was really not standardized until 1953 or so, and it was rare commercially until about the 1960s. So moving on to the founders of this local section, there were four of them who got together and decided we should have a local section of OSA. One of them was Richard Lord, a chemist spectroscopist at MIT. Duncan MacDonald, who was head of the Boston University Optical Research Laboratory. This was not today, had nothing to do with today's photonics lab. And I couldn't find a picture of MacDonald, but he was also one of the first heads of ITech. I think he came in as the head of ITech. Walter Baird, who was an instrument maker, and he, was involved with the creation of applied optics. Ekin Blout, who I had never heard of before, who was developing photographic dyes at Polaroid and later became a biochemist at Harvard. So this is quite a range of people. You'll note there's some industry, there's some academia, and there's some sort of industrial work for the military. The New England section in 1949 had 130 charter members joined that year. So yeah, we did a little better than OSA had done in their start. These were all the people who signed up as members or showed up at sessions. And some of us old timers went through and looked and were able to identify some of them. And I'm going to mention some of them and what the organizations were that they came from. The Boston University Optical Research Laboratory had started out as a Harvard optical laboratory headed by James Baker that was being developed. It was developing aerial surveillance optics. You really need big, high magnifying optics for surveillance when you're flying over enemy territory. And this was a big project for the Air Force, and it was quite successful. After the war ended, Harvard decided they really didn't want to have a armaments factory on the campus, because that's really what it was, and closed the laboratory. Jim Baker was furious. What happened after that was that Duncan MacDonald and presumably others, I don't know any of the details, got together and persuaded Boston University to take over the function of the Optical Research Laboratory, doing aerial research. And they were doing that until Boston University spun out ITech. And this is where ITech came from, was the Boston University Optical Research Lab. So I don't know how many people from the Boston University lab were in the section, because we didn't really, as I said, we were looking at it many years after the fact. Polaroid is another, you might recognize the first name up there, Edwin Land. And but there were a lot of people doing a lot of good work, and there's about 10 names there, and those are ones we recognize, that some of us old timers recognized. Whoops. There was American Optical, Southbridge. American Optical started out as a eyeglass maker in something like 1833. And here there's a lot of people doing ophthalmic optics. Lewis Hyde, who was was OSA president in 1970, and quite a number of people who were involved in lens design, optics, and with some other work that came out that American Optical got into with a few years after that. MIT, we don't know the students, but we found 4 of the most noted professors of the time. Doc Edgerton, the electronic flash developer, Arthur Hardy, who was OSA president in 1935 to 36, George Russell Harrison, the founder of the spectroscopy lab, and Richard Lord, who was one of the founders of the local section. There were people from the amateur telescope makers of Boston. Some of those people had become involved with making fine optics for the aeronautical applications and for the military. And when we're working at Harvard before and some of them, became professional optics people. Catherine McCarthy was a physicist who studied optical crystals at Tufts. She was later became Tufts provost, and she spent a lifetime teaching at Tufts. She started in her early 20s. And Stanley Ballard, who was taught at Tufts for a while and then wandered all over for other culture tiles. And he also was an OSA president. And then soon after 1949, a lot of things happened. NES OSA became the second largest OSA section after Rochester. We were that big. American Optical went into a new research phase where they hired Brian O'Brien, who I showed you earlier, to build a research lab. And he did. He developed the Todd AO widescreen movie, most famed in Oklahoma movie, which was a wonderful broad screen movie. Unfortunately, Michael Todd, the promoter who was involved with this, was killed in a aircraft accident. And they hired Will Hicks, who became a legend in his own time in fiber optics, particularly starting out with imaging optics and going on to communications. And finally, Eli Snitzer developed the first glass laser in 1961 at American Optical. So the Boston section, in fact, I think he talked at the Boston section about his work. So we were right in the cutting edge of the laser business. And iTech was spun off from Boston University and then became a major defense firm. And there were lots more. I mean, there were more optics companies, there were laser companies because lasers were invented in 1960. And with that, I'm going to turn this over to Steve Fantone. Thank you very much.
I want to speak first to those in the back row. So Phil, if I drop my voice and you cannot hear, just raise your hand and I will speak up. So thank you. It really is great to be able to speak to this group. and be part of this celebratory milestone for the organization. My own experience with NES OSA really reflects the culture and character of the organization. I came to work in the Boston area in 1978. I was 25 years old. I was a little bit scared. I want to thank Bill Plummer for having hired me and dragging me into this location, but it has turned out to be one of the great experiences of my life. As I mentioned, it was a little bit scary. I was afraid to go to my first NES OSA meeting. Those meetings were held at ITech, and at the time, you had to go through security, sign in, and sort of get to the other side of the wall. They were doing very important classified work. And, it was just a little bit imposing to get in there. And the meetings were held in the cafeteria at ITech. Now, at that time, ITech was one of the leading places to work if you were in the optical field. They couldn't really talk too much about what they were doing, but we all knew what they were doing. Okay. And they provided their cafeteria to us, and there you got to meet a very interesting crowd of people. And if you look at the alumni group that came out of ITech, whether it was Ellis Patinsky and Lens Design, or Dick Forkey that went on to found Precision Optics Corporation, Ellis Patinsky, Bob Shannon, Jim Wyant, the legacy of people that came out of that organization was really quite remarkable. They were great people. They were thought leaders in the field, and a great legacy of people who have provided leadership in the industry. The meetings became part of my family life. A few years back, or maybe a decade or two back, my wife, Betsy, who's here with me tonight, received a special recognition from this group because she participated in over 75 local section meetings, but she is not an optics person. She's an optics person by osmosis, not by education. It was sort of a date night. My invitation to her would start by saying, "Hey, Betsy, you want to go out for dinner on Thursday?" To which she would say, "Sure, where do you want to eat?" And I would then convince her of what a great meal and evening we would have at a local section meeting. Jeff just provided a great introduction as to the context for the optical field around the time of the founding of the local section. The national organization, OSA then, Optica now, was spawned by the success initially of the Rochester optical community and then the strengths of the local sections across the country. The New England section's members' impact at the national level has been dramatic, with many presidents, officers, fellows, award winners, program chairs, and editors, not to mention authors having been members of the local section, and in many cases, officers in the local section. Many names, some now forgotten or not fully appreciated today, had dramatic impact on the optical industry and OSA governance. They were drawn not just from the obvious academic centers, MIT, BU, and Harvard, but local companies that in their day were the technology leaders. Companies like Polaroid, Bear Atomic, Cook Optical, American Optical, and iTech. Today, the local section masthead shows the transition from these companies to the leading companies in the area today, companies that may have had their transitions, but with OSA Optica members that remain in the field building the next generation of optically oriented companies. Today's keynote speaker, Stuart Elby, is a great example of that, having worked throughout his career for companies that didn't exist or whose fundamental technologies were non-existent and perhaps not even dreamed of when the NES OSA was founded. Presidents of OSA Optica with a tight local section tie. So in the last 75 years, there are at least 13 national presidents: Eric Mazur, Eric Ippen, John Howard, Dudley Williams, Dow Smith, Bruce Billings, Stanley Ballard, James Baker, George Harrison, Richard Lord, Arthur Hardy, and myself, a total of 13 over 75 years, just under 20%. If you were to include those that spent a significant part of their career here, the number is even larger. For instance, Jim Wyant and Bob Shannon. Our members have societal awards include the Ives Medal, that's the highest medal honor by the National Society, the Loam Award, the Richardson Award, the Engineering Excellence Awards, honorary membership, and fellows. Ives medalists include Federico Capasso, Eric Ippen, Herman House, R. Clark Jones, Edwin Land, James Baker, Siebert Duntley, Arthur Hardy, and George Harrison. All of these individuals were giants in their field, but as time passes, as I work down the list, their impact and stature are forgotten. I was very lucky early in my career. I had the opportunity to know and work with many of these individuals, and believe me, they were some of the most interesting projects of my life. The OSA Optica board has been almost continuously had local section alums on it. A big part of the success of the local section has depended on our program chairs to consistently attract great speakers. Great speakers want to speak to great groups, and this section has a reputation of being an intellectually strong and appreciative audience for our speakers. For example, David Lees, who has been, how long have you been doing this? 25 years. He came forward with what he called a highly biased selection of speakers for the last 25 years. It includes 3 Nobel Prize winners, astronauts, members here, Bill Plummer, Eric Mazur, all the locals, Ed Boyden, Tom Brown, Mark Kahn, but also Chris Dainty, Janique Rowland, Duncan Moore, Jeff Heck, all of the major members of leading optical groups across the country and sometimes from around the world. It's really been a remarkable set of speakers that David has been able to facilitate in the last few decades. What is important to note is a strong sense of community among this group and the relationships that have been facilitated to the benefit of the individual members and the community at large, not just here in Boston, but across the country and throughout the world. I'd like to ask those of you that served in the governance of the New England section at one time or another to stand so we can thank you for your service to the community. Yeah, come on, come on. Today, half of Optica's membership is outside the US, yet the impact of local sections is often a key element in the feeling of belonging that we all share with Optica. This section is often used as an exemplar of grassroots self-organization and a governance that best suits addressing the needs of the local optical community. And I want to thank this community for the opportunity it provided me to participate in the governance. And in many ways, it was a training period for me that allowed me to participate in larger governance roles in Optica and OSA. We have a lot to celebrate and be proud of. Thank you very much.
Our next speaker is going to be coming to us remotely. It's going to be Joe Houston, giving the history of ITEC's involvement in the local optics society. It's a really interesting program, but I need about a minute to make sure that his audio can come through the speakers here. So I'd say, Joe, if you can hold on just a moment, and if folks want to take maybe a 3-minute break, grab refreshments, I just got to make sure that we're piping the audio through the speakers so that people can hear Joe's talk. You're not going to want to miss it. So, all right.
Looking good here, Jeff. You're coming through 5 by 5.
Right. Can you hear me? Is it coming out of the speakers?
Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
We hear you loud and clear. We hear you loud and clear. Oh, fantastic.
Roger that.
All right. We'll still take a couple minutes breather right now, Joe.
Well done.
folks, in the interest of keeping things moving, I'd appreciate if folks could come back to their seats. Okay. All right, folks, we're going to resume the talk now. Joe, I think the floor is yours whenever you're ready.
Thanks a lot, Jeff. I'll start off by saying hello, fellow opticers from sunny California. In fact, a little bit too sunny this year. I want to congratulate NES OSA for the 75th anniversary. I guess a question here, I wonder if we have any ex-ITechers in the audience. If we do, could you show a hand? Steve and Jeff, if you could count. Maybe you don't have to use both hands, but be interesting to see how many ex-ITechers are there. I have to start off by saying it's a privilege to be part of this optics explosion that we've been talking about in the last 60 years. And I'm truly honored to join you this afternoon to talk about my experiences. It doesn't seem like 60 years, but you know what they say, the time flies when you're polishing, figuring, and testing a large mirror, and it's gone pretty quickly. Let's go to the next slide. Here's the drill. There are 3 projects that are described in the full text, but we're only going to talk about the first one, and that's Project Corona. And then we'll go to part 2, which deals with the visionaries, pioneers, the people you heard about from Steve. And then finally, I want to touch on some tools and methods that have evolved in the last few years. Most of them have been spin-offs from the Cold War period and the period immediately after, and some of the amazing things that have happened in solid state technology in the last several years. So you can read about the different INTs, image intelligence, so forth later, but now to the next slide. I'm just going to touch on the high points on Project Corona. And as Steve pointed out, it really came in with Colonel Richard Leghorn, highly decorated Air Corps pilot, World War II, flew the beaches of Omaha before the invasion. In 1957, he got $600,000 from Lawrence Rockefeller with the help of Teddy Walkowitz. ITech and went out and purchased Boston University Physical Research Lab, and who was involved in designing cameras at the time. And it started then building cameras for the U2 and the SR-71 under the management of Jim Baker. Next slide, please. I think the best book on ITech and the CIA is the one written by Jonathan Lewis. Excellent, highly recommended. Next slide, please. The Troika here, at that time, Colonel Lou Allen, Carl Duckett, and John Perengowski, who, when he visited ITech, used to go by the name of Mr. P. We all knew who he was. But he didn't wear sunglasses, indoors at least. Next slide. This is a montage of the satellite itself, Corona satellite. And right there on the left, you see the ground coverage. The Corona itself, it weighed about 1,500 pounds, and it had buckets with processed film in it. Those buckets were released from the satellite, parachuted down, and they were captured by C-119 flying above the water. By the way, the buckets were also designed to float. We'll go to the next slide. And probably the best book on the entire project is this book, The Corona Project. It's a full story, and as people who were there at the time recall, it was a Cold War, but industry was on a wartime footing, and that is 24/7. We worked 7 days a week. We had 3 shifts, and those are multiple shifts. And we kept this up from 1959 to 1972. We kept improving the performance through several generations, and we'll talk about those. But next, I'd like to introduce the hero of Corona, the Petzval lens, which was first conceived by Joseph Petzval in Vienna. He was a Slovak math professor, and he had a good advisor by the name of Peter Voigtlander. That's a familiar name in camera makers. Together, they went to the archduke in charge of the artillery. Here we go back to the military. And he hired, and on loan from the archduke, who was head of Austrian artillery, he hired 8 gunners and 3 corporals to do the lens design or the calculations. Simply, it's 2 positive lenses and a stop between and a field flattener. Very, very simple lens. It was selected by Bob Hopkins, University of Rochester, Bob Shannon, and Frank Madden at iTech as the lens of choice. Made a very good choice. Originally, it was the world's first portrait lens, f3.6, 160 millimeter focal length. The first group, positive group there, corrects for a spherical. The second group you see there in the middle corrects for coma. And then there's a field stop between those two, which takes care of astigmatism. However, you wind up curvature of field big time. So we put a field flattener in there, flatten it out so that you can have a flat focal plane for film. Essentially, that's all it is. It does have a distinguishable nodal point about which you can tip and tilt the camera without getting scan smear in the focal plane. So from an overhead satellite that's traveling quite rapidly across the Earth, it's handy to have a panoramic capability without the scan smear. We'll go to the next slide. This is the history of the launches and the successes, but let me sum it up this way. And I'll give you a list of things that happened, like the first 13 launches were failures. Jim Plummer at Lockheed told me that Eisenhower stood behind them. There were 13 failures. 14th was a success. The only thing Ike would say to them, the president would say, keep going, but don't make the same mistake twice. They did that. The project endured for 12 years. It cost $850 million, pretty cheap. Present worth, today's value would be about $6+ billion. That's with a B. They had 130 launches and 94 successes. Not bad. Covered 750 million square miles of territory. It took 860,000 photos. It used 2.1 million with an M feet of Kodak film. The early film was 70 millimeter S-Star, and it was 4 mils thick. Eventually, it became 2 mils thick. It was actually a result of DuPont's breakthrough in Mylar, and it was then licensed to Kodak for photography only. The first generation Corona carried 8,000 feet of film. But when the thickness went from 4 mils to 2 mils, it was able to double that to 16,000 feet of film over 3 miles. In 62 into 63, we transitioned from mono to stereo. And the project that supported all this in Rochester was Project Bridgehead, and that was part of the Hawkeye facility activity, along with Lincoln Avenue. The film resolution was the best ever at that time, and it was 170 line pairs, 170 line pairs per millimeter. In the old days, in the new days, we'd call it 25th wave RMS wavefront. Next slide, please. There were several successor projects, and you're familiar with all of them, I'm sure, but this all comes about from looking at the resolution of spy satellites. Bottom line is that over the years of development from 59, 72, and beyond, we have moved from 10 to 15 feet, the best resolution for Corona, which is sort of like a VW, into 10 centimeters, actually a little bit less with some of the latest projects. Next slide, please. Here's a good example of the successor, a real successor, the KH9 hexagon, produced by PerkinElmer. If you want a really good read on the hexagon, it's Phil Pressel, and his book is entitled Meeting the Challenge, the Hexagon KH9 Reconnaissance Satellite. Fortunately, on October 18, 2023, Phil passed away in Lincoln. And you might want to go back and look at some of his presentations on YouTube. Fascinating. Next slide. Here's a teaser. The notation here says a suspected KH-11 image of the Sapphire launch site. There was an incident there. It's in Iran. It was a disaster, and here's a picture of it. You can blow this up until you can see just a few of the little breaks around the side there. We think it was KH-11 because if you do your math right, you've got a 7'8" diameter optic there. And if you look at that diameter, the wavelength of light and the distance from the target, it equates to about 4 inches, about the size of your hand. So, and beyond that, there's the KH-12, and we won't go into that, but we'll go to the next slide and get on with the program. But I promised there were 3 in the full text, Project Azorian being number 2. I wanted to hesitate here briefly before we go to the luminaries, the visionaries, and just shout out Papa Flash. The success of this mission would not have been possible without Papa Flash. That's Harold Doc Edgerton's strobes. And I wanted to make mention of that before we go on to the next slide. You might also look up YouTube. Now, if we jump to slide number 25, keep your fingers crossed. YouTube is wonderful, but we have to go past the adaptive optics portion. Keep going. There we are, visionaries. You've heard these names before. And it's primarily Joe Goddard, Duncan McDonald, Schwarzschild, Duckett, Baker, Land, and Richard Leghorn. Next slide. All this text in the write-up here is available, as I understand it, locally there. And I won't go and read everything in here, but I want to shout out for Martin Schwarzschild, who really set the stage for modern optical shop practices, and I'll show you why. The next slide, you might want to commit this to memory. These are the goals that Martin set for optics. They've all been met, and the important point here is just about every large optics, especially those in space, goes through some part of this protocol, especially James Webb Space Telescope. Next slide. This set of slides, by the way, just takes you from the testing capabilities in 1962, vacuum tanks, interferometers, contour maps, automatic polishing, and so forth. It takes you through the evolution from PerkinElmer, Martin Schwarzschild, iTech with Dow Smith, all the way through the chambers that were built there. Next slide. And we'll go to the next slide. Including a tilt tank with a laser path interferometer attached, the earliest version. And this was all in 1964, and wind up with computer-assisted optical surfacing, often referred to as chaos. Next slide. And then to the next slide, featuring Aidan and Marjorie Manel, who need no introduction to the community. Other luminaries include the director of the Night Vision Lab in the next slide, and Jim Einson, who lives in Lexington now, but works mostly in Las Vegas. Next slide. Next slide goes to tools and methods, beginning with the earliest version of laser path interferometer and Abe Offner's null lens. Next slide. This is the first laser path interferometer. Commercially available, it was donated to the Optical Sciences Center to Aidan Meinl in 1967 after the patent was awarded. John Pacini left iTech and set up his own company, Pacini Instrument Company, which is illustrated in the next slide. MIC stands for Mickey Mouse. Those of you who were at iTech at that time in optical testing, remember we had the Mickey Mouse Club. It had 3 shifts of 5 to 6 people per shift. Next slide. Paul Foreman, a friend, set up Zygo, came up with the Fazot onychal path interferometer, very popular instrument. And finally, our colleagues, Steve Fantone, and the amazing breakthrough in what we all desired. The next slide. A mid-infrared loopy. Wonderful. Finally, to methods. The latest methods include something called magnetoreological finishing. You know it as RMF. QED Tech is pioneered in that. Came out of Rochester. Codes were applied to Q22 polishing machines. And next slide will illustrate the result. Finally, the last set of slides includes some locals. Synopsis, Mark Can, his company. They do optical system design services. Next capability is Fred. You might say, what is Fred? Fred is Fred. That doesn't stand for anything, but it's Photon Engineering's Jim Harvey and all answer to ray tracing. Very fast, very efficient, does all sorts of analyses. Next slide. Finally, we wind up with some additional methods of collecting intelligence. This is really spying. We're using laser heterodyne systems for blue-green underwater surveillance. Works very well underwater. We're using laser range-gated systems that are invented at iTech by Larry Gilligan. Larry went on to do a special submarine periscope that could take images of other vessels, guess what, underwater. And finally, the last, the photo down there is optical interferometers for geosynchronous orbiting satellite imaging. There's a Navy installation. This is an overhead view of that installation. And with that, we'll wind up with note of appreciation. I want to thank everyone for this fantastic opportunity to walk down memory lane with you. And I'll use a pun, reflect on wonderful friends and colleagues. And I know the work that reviewed this afternoon comes after a lifetime of being in the community. But you recall what Yogi Berra said one time: when you see a fork in the road, pick it up. I have a word of caution. If you do that, be certain that you have mentors and supporters attending, standing by to embrace you along the way. It's rough. On that note, I'll end my formal presentation and turn the meeting back over to Jeff. Jeff, it's all yours.
Thank you very much, Joe. That was very entertaining. Joe's talk is going to be available. He's got his whole monograph in full detail will be available on our website. It's actually a really fascinating read. There's so much more detail than he had time to go through tonight. So with that, I'm going to bring up our keynotes keynote presenter slides for tonight. I'm very excited for Dr. Stuart Elby. All right.